Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Here we are today with one more numerical, and this is also based on oscillation, and we'll be doing some more numericals on oscillations in the coming videos. Hope you all are doing well, and subscribe the channel in case you have not done so yet, and keep watching the videos from the playlist in order to get the most out of it. So here we are with this very short numerical, and so today's video is going to be a very small video, and YouTube is suggesting me that my audience is not watching the entire videos, so it would be a suggestion that in order to understand in a better manner, it is a request to watch the videos fully. Thank you so much for being with me, and this you can just pause the video and go through the question. So in the equation in SI units, so this is in SI units, and the differential equation for a simple harmonic motion is given. So this circled thing is the differential equation, and you are supposed to find out its frequency and time period. So frequency and time period is something we are supposed to get. Now, so this thing I have just mentioned this in given form. So this d square x by dt square is equal to minus 36x is my given data differential equation, and frequency and time period is something we are supposed to find out. Now what we are going to do is we are going to compare this equation with our general equation which we have derived in our previous videos. So comparing this d square x by dt square is equal to minus of 36x to d square x by dt square is equal to minus omega square x. This is our differential equation for linear simple harmonic motion. So if you compare this d square x by dt square, that is the second order time derivative of displacement, x is compared with x, minus is compared with minus, so omega square takes the place of 36. So we can just write omega square is equal to 36. So the omega ka value would be equal to 6. Now here we are not supposed to take the negative value because the time period or the frequency does not go into the negative side, and omega is basically 2 pi f. Omega ka one more formula is that 2 pi f. So I'll take this 2 pi on the other side, so I would get 6 upon 2 pi. 6 upon 2 pi. Now 6 upon 2 pi would be 2 ones and 2 threes, you will get 3 upon, and pi ka value is 22 by 7. Now it's up to you in which you are comfortable. If you wish to write 3.142 or 3.14, you can just put the values and you can solve it by any means. But if you are not comfortable, if you are comfortable in 22 by 7, you can just put it from 22 by 7. I'll move this 7 upstairs, so this will be 7 upon 22, and 7 threes is 21 upon 22. Now dividing this by either by 2 and then 11, or you can just divide it by 22 in case if you remember the table of 22, or you can apply logarithm in case if you want to, or you can, if your board allows calculator, if you are from a board where calculator is allowed, then you can just use the calculator and punch the values and you get the value as 0.9545. I have not solved this for logarithm because this is very easy to solve and it can be directly solved. So it's a personal suggestion, like if your board allows logarithmic calculation, it's still suggested that you do not solve this by logarithm, you solve it by direct method, cancelling it by 2 and then by table of 11. So with that I get an answer of 0.9545. So if you stay with me, when the calculations are difficult, yes, I'll show the logarithmic calculation as well, but right now it is not necessary. Then time period is the reciprocal of frequency, so I can invert this value. So I could have written it's like 1 upon 0.9545, but solving this would surely require a logarithmic table, and which will consume time. So to the boards who a calculator is allowed, this is not an issue, but to the boards which calculator is not allowed and you are supposed to solve by log, then it is going to take some time. So what we have done is, we have, instead of putting value of f from this value here, I have put the value of f from here, 21 upon 22. So that is 21 upon 22. Now this 22 goes up, so I'll get 22 by 21. And again, cancelling by 21 is easier. You just read the table of 7 and then you read the table of 3 and you can get as 1.047 seconds. Because this is a time period, this will be in seconds. Because this is frequency, the unit would be hertz. So I hope you have followed up with this video. Again, you can solve this by any means, calculation, do it by any legal means, and you are through with the correct answer. Thank you so much for watching this video. Stay with me, stay connected with the following videos as well. There will be a lot of numericals on oscillations. Thank you so much. Have a nice day. Subscribe the channel in case you have not done so. Thank you so much. Bye.